All right, guys, here we're going with Fisher projections. Now, Fisher projections are another way to show chiral centers, and they make life a little easier, particularly when we start talking about carbohydrates, which is a whole chapter by itself. So here you have your chiral center. I use WXYZ. There's nothing weird here. I just use these letters to show you there's four different things. What I can do is I can rotate this compound, this molecule in space, and get it to look something like this. We draw it a little differently now. So 2-butanol, which is here, CHOH, this is this. What we're going to do is we're going to turn it vertical. So it looks something like this. And then here's the mirror image. So hopefully you can see that. Down here, instead of drawing all these wedges and dashes, what we're going to do is we're going to just draw a cross there. And that cross indicates there's a chiral center here in the middle where those two lines meet. And that's all. It becomes very easy to draw mirror images. And that's why we use Fisher projections. So what I've done is I've done Fisher projections right here. We did butanol. This is glyceraldehyde. All right, this is a compound. Looks something like this. Not a big deal. All right, I use this one, and then I started drawing only one version of it. I didn't draw the mirror image. I think you guys can see that. So that's what's happening with Fisher projections. I'm not going to bore you to death with that stuff. However, we can draw Fisher projections for compounds with more than one chiral center. And so I want to talk about this with number one, this compound, whoops, right, this compound here. And that's in this area here. I drew, as you can see, Roman numerals 1, 2, 3, and 4. All right. We have this compound and then this mirror image. But then here I have the NH2 on the opposite side, the OH. And we can draw a mirror image of that. This is where vocabulary comes in. 1 and 2 are enantiomers. 3 and 4 are enantiomers. They're mirror images of each other. However, 1 is a diastereomer of 3 and 4. 4 is a diastereomer of 2 and 1. So this is where vocabulary comes up. If I were to ask you to draw a compound, a Fisher projection for a compound, you would only have to draw one. So is in number 2 right here. That's pretty straightforward. But this type of drawing is going to play a role once we start talking about carbohydrates and how they ring up and how they behave. So those are Fisher projections, and that's it for chapter 15.